right, go. Oh, okay, so this problem, this is a really neat problem, but it's complex.
So does that mean it's an absolute value block? Like basically?
Oh, the x greater than 0?
Yeah.
No, it's just this particular problem needed a restriction on the domain, but don't really worry about that. It has more to do with the end result. Okay, this is what we call logarithmic differentiation. I should probably. So the problem we have in this particular problem is that we have a variable as the base and a variable in the exponent. So we cannot use power rule. We can't just, do that, the logarithmic rule. What we're going to do before we start is take ln of both sides. Okay. What this will allow us to do, again, this is, I do have, I think on the practice test, I have to look. I think there's one problem like this, and I actually call it logarithmic differentiation, which gives you a hint in that you have to take the log first of both sides before you can take the derivative. This derivative involves implicit differentiation, okay? So the next step, because we have it's not just y equals, it's ln of y. So I'm going to take dx of both sides. And it's having a delay. Okay. Oh, I'm sorry. I forgot to move the x in front.
Okay, yeah.
Are you okay if I do that in one step?
Yeah. I was waiting. Why didn't she do
So
that?
it's x, I'm going to put the time sign in just so we remember that we have to apply the product rule on the right side. Okay. On the left side, we just learned what the derivative of a natural log, that was 1 over. So it's going to be 1 over y, and then dy dx. That's implicit differentiation. Okay, so the derivative of a natural log is taking 1 over whatever you're trying to differentiate.
Yeah.
And because it's a y, we have to multiply on the dy dx because remember how I said these variables, when these don't match up, the x and the y, we have to multiply that by dy dx. So it's logarithmic differentiation, but you're using implicit differentiation in there. Okay, now I'm going to differentiate the right side. So this is going to be our product rule. Chase?
What is the ln here? ln of y.
The derivative of
is 1 over.
ln is 1 over.
Oh, yes.
So we're going to take the derivative of x, which is 1, times, keep the second one the same. It doesn't matter which one you do first. Plus, now I'm going to keep the x, and the derivative of ln of x is 1 over x. So I have 1 over y dy dx equals, I have ln of x plus 1. Notice that the x times 1 over x would cancel. We're almost done. So remember, what were we looking for? We're looking for dy dx. So that means I need to multiply both sides by y to get rid of
Should we distribute?
I am having like a issue here.
Wasn't the 1 over y times dy over dx cancel the y's?
Hold on. Look. Okay. Now I don't, hold on. I actually don't want to leave y in my answer. Notice I started with y equals and all the x's were on one side. So when I take the derivative, I want it to be in that same format. I want to have dy dx and have just x on my right side. Well,
Divided by y
what's
on the
y
left.
equal to?
X. And that's
X to the x power. So I actually get to go back and plug that in. So I get, I'm going to put it in front, so it's x
Did we do that
to the x.
for one
then
of the
it's a
examples for implicit differentiation?
Yeah, we did this when we did the second derivative.
Yeah, I was doing that with this too.
So, are we done?
Yes.
Wait, what about the one?
Alright, example number
We
7.
just won't do that.
I'm not going to worry about that one.
Okay, good. So, can I pass out the?
You just wrap it up here?
Yeah. Can I do homework problems?
Sure. Yay.
Can I pass it out?
Okay, so that's our
I was
result.
so sick.